Okay, so here is the graph of our line, which we said was y equals 5/3 x plus 4/3. So mathematically, I'm using a function called contour plot.
Okay.
And I'm plotting when y minus 5/3 x is exactly equal to 4/3, x going 0 to 5, y going 0 to 10.
All right.
And so we started out at 1, 3 and went to 4, 8, right?
Cool. Yep.
So now I'm going to change this, just doing what I was doing. Y squared.
You forgot
the square.
Yeah.
Y squared minus 4/3 x squared. So let's see what it looks like.
Alright.
Oh, it's not straight anymore.
It looks like it's straight maybe here,
but
it's got a little curve.
At just the beginning.
Yeah. And I'm going to show you something interesting also that happened.
So it's kind of
So we get,
mirrors.
so it looks like an absolute value function, but there's two of them and it's curved.
Yeah, so if I extend the range, previously it was just one single line,
Yeah.
right?
Yep.
But now,
Two lines.
I get this shape.
It seems like every quadrant has the same part to it.
Well, maybe that's coming from the squaring, but I don't know how it would. Because when you square negative numbers, they're positive.
Yeah.
But then, how are we getting, there's like half of it's negative.
Yeah, well, so here, like, I don't know what this number is here, but let's just call it 2, 2, just to make life simple.
Okay.
Right? So I get y squared minus something times x squared equals something, and if the point 2, 2 is on it.
Okay.
Well, what about the point 2 minus 2?
Well, but that would give you the same result.
Okay, so would that point be on it as well?
Yeah.
What about the point minus 2, 2?
That also gives you the same result.
2 minus
So,
2?
yeah.
So the squaring produces how many copies of the same point?
4.
4, because I have two variables and I square them.
Cool.
And is it 2 times 2 or is it 2 plus 2?
It's
Two.
2 times 2.
Right, so 2 plus 2 would be wrong,
Yeah.
right?
Yeah.
Definitely.
Yeah.
So don't answer 4, instead answer
4.
Yeah.
right. So that's neat. So we don't get a line, we get a curve. And now it looks like it sort of flattens out a little bit, but it in fact is always a curve.
Cool.
This curve is called a hyperbola, and you'll study these a little bit later on.
Okay.
But this is what we were doing, and I can transform to cubes. Now remember, previously I did absolute value before I did the transformations.
So it might look different.
Let's see.
Just got a slight bump.
So let me put the absolute values in. Let me not misspell absolute value.
So it sort of looks like the same thing, but it's like flat right there.
Flattening out. And we saw some flattening when we did higher powers, right?
Yep.
Yeah.
Let's go up to the 10.
It's actually kind of getting to.
Maybe it's gonna look like sort of two parallel lines.
It'd be interesting.
Pretty neat.
Yeah.
Yep.
All right. Good work this morning, guys.